Hello, and welcome to Journey Through Time, the place where curiosity takes a deep breath and imagination meets science. Tonight, we embark on a journey that feels both mysterious and strangely familiar. What if the Earth beneath our feet, the very planet we know so well, is not the first version of itself? Not merely in the sense of dinosaurs, mammoths, or trilobites, but in the sense of civilizations, minds that built, hands that created, societies that may have risen and fallen so long ago that even the rocks themselves barely remember. Before we unfold this idea, pause for a moment. Where are you listening from right now? Perhaps it's a quiet room, or maybe the faint glow of a laptop keeps you company in the evening. Maybe you're wrapped in blankets, scrolling on your phone, or drifting between focus and sleep. Wherever you are, this is the moment we share together. One more among the countless moments Earth has already seen. And if you find comfort in questions without certain answers, please remember to like this video and subscribe, because this little corner of wonder and history grows only when more curious minds find their way here. Now, let's step into the question. If Earth has hosted civilizations before us, how would we even know? Dinosaurs ruled for over 150 million years, an unimaginably vast span compared to the short flicker of human existence. Yet, despite their dominance, they left no cities, no machines, no written words, only bones, footprints, and fragile impressions of feathers pressed into stone. Their legacy belongs to biology, not technology. But civilizations are different. Civilizations leave artifacts of thought. They alter landscapes, generate tools, craft monuments, and change the chemistry of the air and soil. We ourselves are leaving behind plastics in the ocean, steel in foundations, glass in sand, satellites orbiting above. A future species would have no doubt that humanity existed, unless time itself erased us. For Earth is a restless planet. It erases as much as it records. Oceans open and close. Tectonic plates grind and recycle crust. Sediments bury and compress, and whole landscapes vanish into the mantle. Geology is not kind to memory. This raises the haunting question. Could an entire civilization have existed so long ago that Earth has already forgotten it? Scientists have a name for this possibility: the Silurian hypothesis, a thought experiment, not a claim, that asks how we would recognize evidence of an industrial civilization millions of years after it disappeared. If such a society had once flourished, what traces would survive? What would time allow us to see, and what would it erase? Skyscrapers, for example, wouldn't last. Left alone, even the tallest structures would collapse, rust, and dissolve into sediment. In just tens of millions of years, their remnants would be indistinguishable from natural stone. Fossils of wood, fabric, or plastics are even more unlikely. Instead, what might endure are chemical fingerprints, odd spikes of carbon, unusual layers in sediment, traces of metals, or radioactive isotopes that don't appear naturally. And, remarkably, Earth's geological record does show such anomalies, though they are almost always explained by volcanic eruptions, asteroid strikes, or other natural disasters. Yet this thought experiment challenges us. How can we know for certain? What if, hidden within Earth's layers, some anomalies are faint echoes of something more than geology? What if creation and destruction have cycled more than once, with civilizations erased so thoroughly that only chemical whispers remain? If we ask this, we are not only imagining the past, we are also questioning the future. What marks will we leave? Will our plastic, concrete, and isotopes form a clear layer for future beings to find? Or will they too be erased in time, leaving us a forgotten chapter in Earth's book? To contemplate forgotten civilizations is not to summon ghosts, but to remind ourselves how fragile existence is. Even if we are the first, our place is precarious. Even if we are the only ones, our story is temporary. And if we are one of many, then our time is simply another verse in a long and mysterious song Earth has been singing for billions of years. When geologists peer into the crust of the Earth, what they see is not a clear storybook, but a palimpsest, a parchment scraped and rewritten countless times. Sediments lay down their messages, only to be lifted, eroded, or melted away. Mountains rise and then crumble. Oceans spread wide and then close again, dragging the memory of entire landscapes into the mantle. The very surface we walk upon is restless, continually reshaped. That is why the record of deep time is filled with silence and absence as much as evidence. For every fossil we uncover, there are countless others lost forever. This makes the question of ancient civilizations both tantalizing and frustrating. Even if intelligent beings had flourished millions of years ago, how much of their existence could truly survive? A city left untended for a few centuries becomes ruins. A few thousand years later, it may vanish beneath soil, rivers, or desert sands. 1,000,000 years, and it is gone beyond recognition. Extend this across 10 million, 50 million, 100 million years, and the odds fall close to zero that recognizable structures would remain. Instead, what we might expect are subtle anomalies, strange isotopic ratios, abrupt chemical scars, unexplained spikes in carbon or metals, whispers rather than monuments. Consider carbon. Humanity is leaving behind a sharp and unmistakable carbon signature through the burning of fossil fuels. Millions of years from now, if another intelligence were to study Earth, they would find a thin layer of sediment that bears a sudden isotopic shift, a clear sign that something extraordinary happened in our era. Similarly, nuclear activity produces isotopes that do not occur naturally in significant amounts. These traces, though faint, may persist in the geological record for unimaginable spans of time. To future beings, they would be proof that an industrial civilization once altered the planet. If another civilization before us had harnessed energy, burned fuels, or reshaped ecosystems, perhaps their chemical echoes remain too. Yet the challenge is interpretation. Earth has endured countless upheavals, massive volcanic eruptions, asteroid strikes, runaway climate events. Each of these leaves behind scars that could mimic the traces of industry. A sudden warming in the geological record could be our doing, or it could just as easily be lava flooding the land. A strange layer of metals might be residue of mining, or simply dust from a meteor impact. The planet remembers chemistry, but it does not label its memories. This is why the Silurian hypothesis is valuable. Not because it proves anything, but because it forces us to ask better questions. If our own presence could be erased so easily, how confident can we be that no others came before? Perhaps entire civilizations rose and fell, their knowledge lost, their monuments dissolved, their stories erased by the endless recycling of the crust. Perhaps their only legacy is a spike in sediments we have not yet recognized for what it is. The silence of the fossil record deepens this mystery. Fossilization is rare, and even dominant species leave behind only fragments. Dinosaurs, who ruled Earth for more than 150 million years, are known from scattered bones, teeth, and imprints. For all their dominance, their memory is incomplete. Entire lineages of soft-bodied creatures vanished without leaving a trace. Even early humans, who lived only a few million years ago, are known from a handful of skeletons and tools. If our own ancestors are so faint in the record, what chance would a vanished civilization from hundreds of millions of years ago have? And then, there is the problem of scale. We measure time in decades, centuries, perhaps millennia. But Earth's story is written in millions and billions of years. Human civilization itself is only about 10,000 years old. A blink, less than the thickness of a page in the planet's archive. Against that backdrop, even an advanced civilization lasting 100,000 years would vanish, almost without a trace. The silence is not proof of absence. It is proof of how little survives the eraser of time. Yet in this silence lies something humbling. The Earth remembers catastrophes best: the sudden, the violent, the abrupt. The asteroid that ended the age of dinosaurs left a clear boundary. A thin layer of iridium spread worldwide, a global scar. Enormous volcanic eruptions left vast deposits of basalt and chemical fingerprints that shout of fire and smoke. If civilizations before us altered the planet on a global scale, perhaps their echoes linger in similar scars, layers of anomalies waiting to be reinterpreted. But civilizations do not always collapse in explosions. Sometimes they fade quietly, slowly eroded by their own fragility or by the patient hand of nature. If intelligence before us lived in harmony with ecosystems, altering them without towering monuments, would we even recognize their presence? If they worked with organic materials, biodegradable structures, or even biology itself, their marks might have blended seamlessly into what we now mistake as natural evolution. Perhaps their greatest achievements were invisible to geology. Perhaps what remains are only puzzles we haven't yet learned how to read. This is the paradox. To search for echoes of forgotten civilizations, we must look not for artifacts, but for disturbances in Earth's rhythm. Something out of place in the chemistry of sediments. Something unusual in isotopic balances. Something that whispers of intelligence rather than accident. Yet the closer we look, the more we realize how thin the line is between geology and culture, between accident and design. And in that uncertainty, the question lingers. Are we truly the first, or are we simply the first to remember? When we think about history, we often imagine it as progress, an upward climb from primitive caves to modern skyscrapers, from stone tools to satellites orbiting the sky. Yet Earth's own story tells us something very different. The planet does not move in straight lines. It moves in cycles of creation, destruction, renewal, and loss. To walk through the geological record is to see this rhythm etched again and again. Flourishing worlds swept away, only to be followed by new beginnings. Nowhere is this clearer than in the mass extinctions that punctuate the timeline of life. There have been 5 great die-offs, each one ending an age and beginning another. Around 443 million years ago, the Ordovician extinction wiped out most marine species after a sudden ice age followed by rapid warming. The Devonian extinction struck about 360 million years ago, erasing early reef systems and countless fish species. Then came the most catastrophic of all, the Permian extinction, often called the Great Dying. Some 252 million years ago, more than 90% of species vanished in a geological instant. Imagine nearly every plant, every animal, every ecosystem collapsing at once. Afterward, life began again, reshaping itself in the empty spaces. Dinosaurs rose to dominance after the Triassic extinction. They reigned for more than 150 million years, until another cataclysm ended their age, the Cretaceous extinction, 66 million years ago, when an asteroid impact changed the planet in a single day. The skies darkened, climates shifted, ecosystems collapsed, and yet, From the ashes, new creatures flourished. Mammals, once small and overshadowed, spread across the earth and eventually gave rise to us. These cycles remind us of something humbling. Destruction is not rare. It is the rule. Life thrives, then falters. Entire lineages vanish, and yet the planet always begins again. Forests grow after glaciers retreat. Coral reefs recover after seas rise and fall. Even mass extinctions, which feel like endings, are only transitions, doors closing so that others may open. Now consider civilizations within this pattern. If intelligence has emerged before, it would have been subject to the same merciless rhythm. No matter how advanced, no matter how ambitious, it would face the possibility of sudden ruin. Volcanoes, asteroids, climate shifts, pandemics, or even its own mistakes. Intelligence would not stand outside the cycle. It would be swallowed by it, just like trilobites, ammonites, and dinosaurs before it. And if that happened tens of millions of years ago, what traces would survive today? Perhaps none that we could easily recognize. The silence of the record does not deny the possibility. It only shows us how fragile memory is when written in stone. Consider how little remains, even of our own ancestors. The vast majority of human history is already gone, dissolved into the soil, or lost in forgotten words. The first cities, only a few thousand years old, are ruins already. Libraries have burned, archives have crumbled, oral traditions have faded into silence. If this is true for mere millennia, what chance has anything from tens or hundreds of millions of years ago? And yet, Earth does remember certain things. It remembers in chemistry, in scars, in sudden shifts. When geologists read layers of rock, they see abrupt changes, boundaries between worlds. A thin layer of iridium tells the story of the asteroid that killed the dinosaurs. Basalt flows whisper of massive volcanic eruptions that nearly sterilized the planet. Coal seams mark ancient forests compressed by time, while limestone cliffs hold the shells of seas that vanished long ago. Earth remembers not in words, but in signatures. If earlier civilizations existed, their signatures might also be there. Not monuments, not cities, not tools, but subtle disturbances. A carbon spike, an isotopic anomaly, unusual metals in sediments, something out of rhythm with the natural cycles. The problem is interpretation. Nature itself produces anomalies all the time. To tell whether a scar in the record was carved by geology or by culture is nearly impossible. But the fact that we can even ask this question means that the door cannot be fully closed. There is another aspect to these cycles. They remind us how small we are in scale. Human civilization, from the first farming villages to today's sprawling megacities, spans only about 10,000 years. In geological terms, that is barely a breath. 100,000 years would still be a blink. And yet, for us, it feels like forever. Our perspective is too short to see the rhythm of rise and collapse that has defined Earth's story from the beginning. We imagine permanence where there is only transition. And perhaps that is the deeper meaning of the forgotten civilizations question. It is not only about whether others walked here before us. It is about what our own place means within the rhythm. If intelligence is rare, we may be the first. But if it is not, then we are one more verse in a very old song, destined to fade like those who may have come before. Either way, the lesson is the same. We are not outside the cycle. We are inside it, vulnerable to its erasures, temporary in its memory. And yet, there is beauty in this fragility. To realize that even in the face of vast destruction, life always returns. That creation is never truly gone, only reshaped. That our moment brief though it may be, is part of something larger, a cycle stretching back billions of years and forward into futures we cannot yet imagine. When we imagine the past, we often picture it carved in stone, fossils laid out in neat layers, bones turned to minerals, ancient forests petrified into rock. We imagine permanence. But the truth is almost the opposite. The record of Earth is not stable. It is fragile, selective, and full of silences. For every fossil in a museum case, there are countless others that dissolved, decayed, or were erased before they could ever be preserved. This is why scientists sometimes call time the Great Eraser. The Great Eraser works slowly but relentlessly. It does not destroy everything at once. It simply waits. Skyscrapers collapse into rubble. Rubble is buried in soil. Soil hardens into sediment. Sediment turns into stone. Over millions of years, the outlines blur until no trace remains. Even the strongest human monuments, the pyramids, great dams, concrete towers, are powerless against this patience. Wind, rain, earthquakes, glaciers, and the endless churn of plate tectonics ensure that nothing stands forever. Even the ocean, which feels eternal and vast, is one of the most thorough erasers of all. Wooden ships vanish within centuries on the seafloor. Metal hulls corrode and crumble. Organic remains dissolve. In a few thousand years, almost nothing recognizable is left. Stretch that to millions of years, and the oceans become spotless chalkboards wiped clean, except for rare pockets of sediment that hold chemical memories. If a city had once stood on what is now seafloor, its remains have already been melted back into magma, reborn as new crust, erased without a whisper. This is the challenge of imagining forgotten civilizations. If intelligent beings once flourished in deep time, what chance is there that any of their works survived the eraser? Fossilization itself is rare, dependent on extraordinary conditions. Artifacts of wood, bone, cloth, or metal decay in a few thousand years, unless sealed in unusual environments. Plastics degrade under sunlight and pressure, fragmenting into particles too small to be recognizable. Even glass, which feels timeless, eventually weathers back into sand. In a million years, these materials would not look like artifacts. They would look like minerals or chemical oddities buried in stone. And yet, some things survive. Bones rich in minerals can fossilize. Insects in amber endure in astonishing detail for tens of millions of years. Footprints hardened in ancient mud can outlast the creatures that made them. Tiny air bubbles trapped in ice or gas sealed inside rocks can tell us what the atmosphere was like eons ago. These survivors remind us that Earth is not a perfect eraser. It is a selective one. It forgets almost everything, but it remembers in fragments. For paleontologists and archaeologists, this selectivity is both gift and curse. It gives us enough scraps to reconstruct the outlines of ancient worlds, but never the full picture. It forces us to interpret, to imagine, to fill in gaps with careful inference. And sometimes, interpretation itself is fragile. A strange chemical layer could be volcanic ash, or it could be something else. A spike of carbon could be natural, or it could be cultural. The silence between fragments leaves room for both humility and wonder. This fragility is why the Silurian hypothesis resonates so deeply. Its core is not the claim that there were forgotten civilizations, but the reminder that time erases far more than it preserves. If we disappeared tomorrow, what would remain in 10 million years? Perhaps a thin carbon layer from fossil fuel burning. Perhaps isotopes from nuclear activity. Perhaps a faint chemical ghost of plastics in sediments. But our cities, our libraries, our digital clouds, all of them would be gone. Without context, our memory could look indistinguishable from natural events. A future geologist might see our footprint as just another anomaly in Earth's restless rhythms. And so, when we ask whether others came before us, we are really asking how confident we can be in fragments that escaped the eraser. We know dinosaurs ruled for 150 million years, and yet we reconstruct them from bones that are astonishingly rare. We know vast forests once covered continents, yet much of their memory is compressed into anonymous seams of coal. If this is the record for creatures and landscapes that lasted millions of years, what hope is there for a civilization that rose and fell in a fraction of that time? The paradox is unsettling. We long for permanence, and so we build monuments as acts of defiance against forgetting. Stonehenge, the pyramids, the Great Wall, all are attempts to carve memory into Earth itself. And yet, even these fade. Inscriptions wear down, stones shift, earthquakes topple. Over geological time, they are as temporary as castles of sand. The eraser is impartial. It does not care for glory or pride. Kings and farmers, palaces and huts, all meet the same fate in its patient hands. But there is another side to this eraser, a side often overlooked. By clearing the old, it makes room for the new. Glaciers retreat and forests grow. Volcanic plains are scoured and fertile soil emerges. Coral reefs collapse and new reefs rise in their place. Civilizations themselves, when they fall, leave behind ruins that become the foundations for others. The eraser does not stop the story. It simply ensures that no chapter dominates forever. It is cruel to memory, but kind to renewal. And so, when we wonder about forgotten civilizations, we are also forced to reflect on ourselves. Our monuments may not last. Our technologies may fade into dust. But what we changed, the chemistry of the air, the isotopes in the soil, the plastics fused into stone, those may endure as shadows, faint whispers in the planet's record. We will be remembered not by our stories, but by our effects. That is the legacy time allows. It is a humbling thought that even our greatest works may dissolve, while a thin chemical scar in the sediment may outlast us all. If earlier civilizations walked this earth, perhaps their shadows are already here too, waiting, faint, and unrecognized in the vast silence of geological memory. When we think about archives of history, we imagine stone tablets, scrolls in forgotten libraries, or fossils locked in rock. But one of Earth's greatest record keepers is not stone at all. It is the air above us. The atmosphere is a restless, invisible archive, carrying the signatures of every breath, every fire, every eruption, every industrial act. Though fragile, it remembers. Scientists today use ice cores drilled from Greenland and Antarctica as time machines. Each layer of ice corresponds to snowfall compacted, year by year, century by century. Within those frozen layers are tiny bubbles of air sealed since the day they formed. By analyzing them, researchers can measure carbon dioxide levels, methane concentrations, even the faint traces of volcanic eruptions or ancient wildfires. Some of these records stretch back hundreds of thousands of years, providing astonishingly detailed timelines of climate and chemistry. Now, imagine an intelligent species, millions of years ago, altering its atmosphere. Perhaps they burned fuels, releasing massive amounts of carbon. Perhaps they split atoms, leaving behind isotopes never naturally found in large amounts. Perhaps they even created synthetic chemicals, molecules alien to nature. Would any trace of that remain today? Possibly yes, though faint and fragmented. Like echoes of whispers caught in stone, atmospheric anomalies can linger in sediments, in rocks, in chemical ghosts. We know this because we are doing it ourselves. The combustion of fossil fuels has shifted the ratio of carbon isotopes in the air. Plants prefer lighter isotopes, so fossil fuels, derived from ancient plant matter, carry a distinct chemical fingerprint. When we burn them, we alter the balance of carbon-12 and carbon-13. Future geologists, millions of years from now, will be able to detect this unmistakable signature. Nuclear activity leaves behind isotopes like plutonium-244, which do not occur naturally in measurable quantities. Synthetic chemicals like CFCs, once used in refrigeration, are wholly artificial. Though they break down over time, they may leave faint chemical ghosts that endure in soils and sediments. If another civilization had once altered its air in similar ways, those faint fingerprints might still exist in the geological record. But here lies the difficulty. Nature also creates anomalies. Volcanoes release vast amounts of carbon and sulfur. Methane bursts from the ocean floor. Asteroid impacts inject strange compounds into the skies. Climate shifts leave marks that could be mistaken for industry. The challenge is interpretation, deciding whether an anomaly is natural or cultural, when Earth itself does not annotate its memories. The oceans, too, are vast archives. Beneath the restless waves, the seafloor accumulates layer upon layer of silt, mud, and microfossils. Each layer is a page in a book that has been writing itself for millions of years. The skeletons of plankton fall gently to the bottom, their chemistry recording the temperature and acidity of the water in which they lived. Dust from continents, ashes from distant volcanoes, even traces of cosmic events drift downward and are locked into the sediment. Year after year, century after century, the ocean floor becomes a library of mud, quietly storing the story of Earth. Scientists drill cores into these sediments to pull out cylinders of history. By studying the chemistry and fossils within, they reconstruct climates, ocean currents, and atmospheric shifts, stretching back millions of years. It is through such cores that we know about sudden warming events, abrupt extinctions, and long cycles of glaciation. If a civilization once altered the planet, the oceans might be where its fingerprints remain, hidden deep, waiting to be read. Consider plastics. Today, plastics are so widespread that geologists have coined a new word, plastiglomerate, rocks that form when melted plastic fuses with sand, shells, or volcanic lava. Along coastlines, these strange hybrid stones are already appearing. In the far future, long after bottles and bags have crumbled, plastiglomerates may endure as markers of our time. If another civilization ever created anything similar, their equivalents could lie buried deep beneath ancient sediments, still waiting for recognition. Or think of heavy metals. Mining and industry redistribute elements like lead, chromium, and mercury in ways that nature rarely does. These concentrations end up in sediments where rivers flow to the sea. Millions of years from now, future geologists might see these spikes as unmistakable signs of industrial activity. And yet, volcanoes too can flood the oceans with metals. Cosmic dust can scatter unusual elements across the globe. Once again, the interpretation is uncertain. The traces are there, but the meaning is elusive. The deep ocean holds another kind of memory, biological shifts. The microfossils of plankton can reveal sudden stress, unusual chemistry, abrupt changes in species abundance. If an industrial civilization had altered climate or ocean chemistry, perhaps it would show up in these tiny skeletons. A spike of carbon, a sudden die-off, a shift in species balance. All could whisper of disturbances that nature alone might not explain. But would we recognize them as such? Or would we dismiss them as another unexplained warming event, another volcanic surge, another accident of geology. This is the heart of the problem. The evidence for civilizations in deep time may look almost identical to natural events. A sudden warming could be industry, or it could be lava. An unusual layer of isotopes could be nuclear fallout, or a meteor strike. A spike of metals could be mining, or volcanic ash. The planet remembers, but it does not label. Without context, its memories are ambiguous. And yet, the very possibility that anomalies might be cultural rather than natural is enough to keep the question alive. Could the Paleocene-Eocene thermal maximum, about 56 million years ago, with its rapid warming and carbon surge, have been the footprint of industry? Scientists believe it was natural, but the fact that we cannot completely rule out other interpretations shows how faint the line is between geology and culture when we zoom out across millions of years. Perhaps the most humbling truth is this: if we vanish tomorrow, the same uncertainty will apply to us. In 10 million years, our skyscrapers will be gone. Our books and servers will be dust. Our monuments will be crumbled into rubble, then sediment, then stone. What will remain are chemical whispers, isotopes, carbon ratios, plastiglomerates, subtle scars in the ocean floor. Future beings might puzzle over them, just as we puzzle now. Was it volcanoes? Was it a meteor? Or was it something else? Something intelligent? Something forgotten? And in that ambiguity, the question of forgotten civilizations does not fade. It deepens. It forces us to realize how fragile memory is and how easily our own existence could dissolve into the noise of natural history. From space, Earth looks serene, a blue sphere swirled with white clouds, green continents, and icy poles. But beneath that calm exterior lies a restless machine. Earth is not static. It does not simply sit and preserve the past like a museum. It is in constant motion, recycling itself, breaking down old surfaces and creating new ones. This is why its memory is so fragmented. Unlike the moon, which bears scars billions of years old, Earth continually erases its own story. The engine of this erasure is plate tectonics. The crust of the Earth is not one solid shell, but a mosaic of plates floating atop the hot mantle. These plates drift slowly, only a few centimeters each year. Yet over millions of years, that slow drift rearranges entire continents. Oceans open and close, mountains rise and wear down, land masses drift from pole to equator and back again. With each shift, the record of the surface is folded, buried, or destroyed. Oceanic crust, in particular, is temporary. At mid-ocean ridges, molten rock rises and creates new crust. This crust spreads outward and eventually plunges back into the mantle at subduction zones. The cycle is relentless. On average, the floor of the oceans is no more than 200 million years old. To human minds, that sounds unimaginably ancient. But compared to Earth's 4.5 billion years, it is fresh paint. This means that if a civilization had thrived on a continent that later sank beneath the sea, its traces are gone. Subducted, melted, and reborn as new crust, erased so completely that no whisper remains. Even continental crust, which is older and more stable, is far from permanent. Continents fracture and collide. Sediments are buried, compressed, and lifted as mountains. Erosion grinds them back down. Glaciers carve valleys. Rivers wash entire landscapes into the ocean. Volcanoes resurface the land with fresh layers of lava. In this constant reshaping, history is not preserved, it is rewritten. Like a chalkboard used again and again, Earth keeps writing over itself. This process is both destructive and creative. Without tectonics, the planet would not be habitable. The recycling of crust drives the carbon cycle, stabilizing climate across millions of years. It replenishes soils, forms new minerals, and renews the environment for life. Yet it comes at the cost of memory. The more dynamic a planet is, the less it remembers. Venus, for example, appears to have undergone massive resurfacing events that wiped its history clean. Mars, though quieter now, once had colossal volcanoes that reshaped its surface. Even the Moon has been endlessly scarred by impacts. No world is still, but Earth is especially thorough in its renewal. For the question of forgotten civilizations, this is devastating. The window of time in which durable traces might survive is narrow. A monument carved into rock could endure for thousands of years, perhaps even hundreds of thousands. But over millions, tectonics would bury it, erode it, or recycle it completely. Even plastics, which feel indestructible to us, would fragment and break down, eventually becoming indistinguishable from natural sediments. Only chemical fingerprints, anomalous isotopes, spikes of carbon, unusual mineral deposits, stand a chance of surviving the churn of deep time. This recycling forces us to ask a difficult question. How can we be sure we are the first? The geological record is a patchwork of fragments. Entire ages are missing, erased by erosion and tectonics. We know that life has flourished on this planet for billions of years. Complex organisms have existed for hundreds of millions. Within that vast span, there is room for rises and collapses that we might never detect. Even a civilization, lasting 100,000 years, a span far longer than our own, would be a blink compared to geological time. Once erased, it might leave only the faintest of traces, if any at all. Think of what would happen if humanity vanished today. Our cities would crumble within centuries. Forests and rivers would reclaim our roads. In a few thousand years, most of our monuments would be buried or eroded. In a few million years, tectonics would have reshaped the land so thoroughly that little would remain. Perhaps a thin chemical layer in sediments. Perhaps fragments of plastiglomerates. Perhaps isotopic scars from nuclear activity. But not the monuments we imagine define us. The record of our age would be ambiguous, easily misinterpreted as a natural event. This is the humbling truth. Permanence is an illusion. Even the continents beneath our feet are temporary arrangements. The mountains we admire as eternal are already being worn away. The seas we think of as timeless are opening and closing in cycles. Earth is a recycler, not an archivist. Its goal is not to remember, but to renew. And yet, this very impermanence may explain why civilizations, if they ever arose before, are so hard to detect. We expect monuments, artifacts, tools. But what we should expect are shadows, disturbances in chemistry, scars in sediments, anomalies in isotopes, not obvious cities, but subtle fingerprints. If we are to find evidence of forgotten civilizations, it will not be in ruins, but in the whispers of stone and sea. What makes this perspective powerful is that it reflects back upon us. We like to think our presence is indelible, that satellites in orbit, skyscrapers, and digital archives will somehow mark us forever. But in the eyes of geology, these are fleeting. The planet will recycle them just as it recycled everything before us. Our true legacy will be measured not by what we built, but by what we changed. The chemical echoes in air and water, the isotopic scars, the redistribution of metals, these are what the Earth will remember. So when we wonder whether others came before us, we are also forced to consider how we ourselves will be remembered. Or, if we will be remembered at all, perhaps a future intelligence, millions of years from now, will puzzle over faint anomalies in sediments, debating whether they were caused by volcanoes, meteors, or industry. Perhaps they will ask the same questions we ask now. Were we alone? Were we the first? Or are we simply another forgotten chapter in a book that Earth keeps rewriting? When we imagine technology, we think of shining machines, glowing cities, satellites in the sky, vast networks of roads, dams, and skyscrapers. These seem like the most permanent markers of an age. And yet, through the eyes of geology, they are not monuments at all, but shadows. Brief impressions that dissolve almost as soon as they appear. Time is merciless to artifacts. But what time cannot so easily erase are the consequences. Technology leaves behind not just objects, but signatures, and these may endure longer than the machines themselves. Consider our own civilization. In 1,000,000 years, no skyscraper will stand, no car will be intact, no book will remain readable. The internet will vanish entirely, erased within decades if left unmaintained. But in the rocks and sediments, subtle signs will persist. The sudden isotopic shift from burning fossil fuels, the presence of synthetic isotopes from nuclear testing, the plastiglomerates fusing plastic with natural rock, the redistribution of rare metals across the globe. These are not artifacts in the traditional sense. They are shadows of technology. They are fingerprints left behind when the objects themselves are long gone. This is why the Silurian hypothesis challenges us to think differently. If earlier civilizations existed, we should not expect to find intact tools or monumental ruins. We should expect to find disturbances, chemical scars that do not fit natural rhythms. Perhaps a thin layer rich in unusual isotopes. Perhaps a spike of heavy metals not easily explained by volcanic eruptions. Perhaps sudden biological stress visible in microfossils, pointing to pollution or environmental disruption. These would not shout their origins. They would whisper. But the whispers could still be heard if we know how to listen. The difficulty is that nature itself leaves similar marks. Volcanic eruptions flood the atmosphere with sulfur and carbon. Asteroids scatter iridium across the globe. Methane bursts from ocean floors can alter climate in ways that mimic industrial emissions. Even mass extinctions, which look catastrophic in the record, can be explained by purely natural events. The challenge is separating what might be cultural from what is geological. And without context, the line is blurry. To a geologist millions of years from now, our current carbon spike may look no different from one caused by ancient volcanic eruptions. But perhaps that is exactly the point. If civilizations rose before us, their legacies would not be monuments, but enigmas. Anomalies that we debate, anomalies that we might misinterpret as natural events. The Paleocene-Eocene thermal maximum, 56 million years ago, saw global temperatures rise by up to 8 degrees Celsius in a relatively short time. Carbon levels surged. Ecosystems were disrupted. The leading theory is volcanic or oceanic methane release. But to a future geologist, our own footprint might look much the same. What if events like these were not only natural? What if some were also the shadows of forgotten technologies? Technology also leaves behind redistributions. Mining, smelting, drilling, all move elements in unnatural ways. Humanity has pulled billions of tons of iron, copper, aluminum, and rare earths from the ground, concentrating them in forms nature does not create. Over time, these will corrode and return to the crust. But traces of those redistributions may persist in sediments. If another civilization once mined, their footprints may also linger, not as machines, but as subtle imbalances in geology. There is another, even stranger possibility. What if ancient civilizations did not use metals or plastics at all? What if their greatest achievements were biological rather than mechanical? Perhaps they manipulated life itself, altering genes, creating organisms to serve their needs. Such changes might not leave obvious artifacts. They might appear instead as sudden shifts in evolution, genetic anomalies, or ecosystems that behave in ways we do not fully understand. To us, it would look like ordinary natural history. Yet in truth, it could be the faint afterimage of intelligence. This thought forces us to widen our imagination. We often assume intelligence looks like us: cities, machines, fire, metal. But perhaps intelligence can take forms we do not recognize. Perhaps it can rise and fall without leaving behind structures we would call civilization. If so, then the shadows of technology may already be around us, hidden within biology, within chemistry, within puzzles we cannot yet decipher. We may be surrounded by echoes without realizing it. And then comes the most sobering realization of all. Our own story will also fade into shadow. Our libraries will burn or rot. Our monuments will crumble. Our digital memory will vanish shockingly fast. Servers lasting decades, paper centuries, stone perhaps thousands of years if sheltered. But none of it will endure deep time. What will endure are our shadows. The carbon in the air, the isotopes in the soil, the altered sediments in the ocean. That is the true record of humanity. That is what the earth will keep. This means that the measure of a civilization's permanence is not in its monuments, but in its chemistry. If others came before us, perhaps their shadows still whisper in anomalies we have not yet understood. If none came before, then we are the first, and our shadows will one day become the faint whispers that others debate. Either way, permanence is an illusion. In the eyes of deep time, technology is not an object. It is a shadow, cast briefly, then gone. And so the question remains: if we want to know whether forgotten civilizations walked this earth, we must not search for ruins. We must learn to read shadows. When people picture the fossil record, they often imagine it as a vast gallery, a crowded museum where bones, shells, and imprints line up neatly, telling the story of life in order. Museums reinforce this image with towering skeletons, delicate fern imprints, trilobites frozen in stone. But this vision is misleading. The fossil record is not full. It is mostly empty. It is not a library, but a collection of torn pages scattered in the wind. Fossilization is extraordinarily rare. Most creatures that ever lived vanished without leaving a trace. Their bodies decayed, dissolved, or were scattered before sediments could bury them. Even with dominant species, the record is fragmentary. Dinosaurs, who ruled Earth for more than 150 million years and covered every continent, are known from incomplete skeletons, scattered bones, and the occasional impression of feathers or skin. For all their dominance, the surviving evidence is astonishingly thin. Now consider softer-bodied creatures: jellyfish, worms, insects, early mammals. Their chances of preservation are almost zero unless conditions were exceptional. Whole lineages have risen and fallen, leaving almost nothing behind. Even with human ancestors who lived only a few million years ago, the record is sparse: a handful of partial skeletons, teeth, and tools. Vast stretches of our own evolutionary history are shadows, reconstructed from fragments. This silence matters because it reveals how much is missing. We know life has flourished on Earth for billions of years, yet the story we reconstruct is patchy, biased, and incomplete. Some environments preserve fossils well: river deltas, calm seas, tar pits, caves. Others, mountains, deserts, forests, erase almost everything. What survives is not a complete record, but an accident of conditions. That means entire worlds may have existed, vibrant with life, and left almost no trace for us to find. If this is true for biology, what does it mean for civilization? If intelligent beings had once walked the earth millions of years ago, would we expect their bodies to fossilize? Unlikely. Their numbers may have been small compared to the herds of ancient animals. Their bodies, unless buried under unusual circumstances, would have decayed like most others. The chance of us finding even one fossilized skeleton would be vanishingly low. Artifacts, too, face the same problem. Pottery shatters, metal corrodes, textiles rot, wood burns or decays. Even stone tools, which feel durable, erode and fracture over time. A few thousand years might preserve them. A million years might not. Over tens of millions, the chance falls close to zero. Unless buried in stable sediments or caves, they dissolve into absence. This creates a paradox. We assume that if civilizations had existed before us, their traces would be obvious. Ruins, tools, skeletons. But the truth is that the record is already so empty that their absence tells us little. If we can lose so much of known history, why not entire ages of forgotten history? The silence in the fossil record is not proof of absence. It is proof of how fragile presence is. Scientists already wrestle with this silence. Whole species seem to vanish abruptly, with no clear ancestors or transitional fossils. New species appear suddenly, without obvious precursors. Sometimes this is explained by incomplete discovery. Sometimes it is the result of catastrophic events that erased lineages before they could be preserved. But always, the silence looms larger than the evidence. The record is not a complete story. It is a fragmented whisper. In this light, the hypothesis of forgotten civilizations becomes less far-fetched. If vast ecosystems of plants and animals can vanish with barely a trace, why not cultures, technologies, or intelligent beings? If the bodies of billions of creatures leave behind only a scattering of bones, why would we expect a handful of cities to endure millions of years? The silence that already surrounds us leaves space for the possibility. This silence also forces humility. Paleontology is an act of inference, stitching together worlds from scraps. A single tooth can redefine species. A jawbone can rewrite evolutionary trees. But what of the things that left no fossils at all? What of the stories erased so thoroughly that nothing remains? Those cannot be reconstructed. They are gone. And within those gaps, we must allow for mystery. Perhaps this is why myths and legends of forgotten ages resonate so deeply. Cultures across the world tell of floods, fires, cycles of creation and destruction, worlds before this one. While we should not mistake myth for geology, it is striking that human imagination so often returns to the idea of lost civilizations. Perhaps it is instinctive recognition of how fragile memory is. Perhaps it is an echo of real events dimly remembered. Or perhaps it is simply the mind's way of grappling with the silence, the vast unknown where the record is missing. The fossil record, then, is both a guide and a warning. It shows us that life is resilient, adapting through endless cycles. But it also shows us how easily evidence vanishes. For every fossil displayed in glass, there are countless stories erased. If earlier civilizations existed, their memory may lie not in bones or tools, but in the gaps, in the silence that surrounds us, in the pages of history that time has already torn away. And so, the question deepens: are we truly the first? Or are we simply the first to notice how much is missing? Long before geology and paleontology gave us scientific frameworks for understanding Earth's past, humanity already carried stories about forgotten ages. Myths, legends, and sacred texts from cultures around the globe speak of worlds destroyed, of civilizations swallowed by oceans, of fires that consumed entire peoples, of golden ages followed by collapse. These stories are not evidence in themselves, but they are striking in their persistence. Why do so many cultures imagine cycles of destruction and renewal? Why do tales of lost civilizations echo across continents, carried in different languages, yet sharing the same themes? Consider the myth of Atlantis, told by Plato in his dialogues. According to the story, Atlantis was a great and powerful civilization, advanced in technology and influence, until it was destroyed in a single catastrophic day and night, swallowed by the sea. Scholars debate whether Plato meant this as allegory, morality tale, or historical memory. Regardless, Atlantis has endured for millennia as the archetype of a lost world. Or take the flood myths that exist on every continent. In Mesopotamia, the Epic of Gilgamesh tells of Utnapishtim, who survived a deluge sent by the gods. In the Hebrew Bible, Noah builds an ark to preserve life from divine floodwaters. In Hindu tradition, Manu is warned by a god, in the form of a fish, to build a boat that carries the seeds of humanity through cosmic waters. Among Native American tribes, from the Hopi to the Ojibwe, there are stories of great floods that reshaped the earth and forced survivors to begin anew. Different cultures, separated by oceans, converged on the same imagery: destruction by water, survival through preservation, and the rebirth of humanity. Fire, too, is a recurring destroyer. In Norse mythology, the world ends in Ragnarok, consumed by flames and chaos, only to be reborn anew. In Hindu cosmology, time itself is cyclical, with vast ages called yugas. Each age ends in destruction, sometimes by fire, sometimes by flood, before a new cycle begins. The Maya and Aztec civilizations also spoke of previous worlds, destroyed in succession before the current one arose. To them, the universe itself was a rhythm of creation and erasure, with human beings inhabiting only the latest age. Even Greek mythology is threaded with the idea of forgotten ages. Hesiod described 5 ages of man: the Golden Age, Silver Age, Bronze Age, the Age of Heroes, and the Iron Age. Each age declined from the last, marked by loss, corruption, or destruction, until humanity reached its present state. The Golden Age was remembered as a time of harmony and abundance, lost forever, while later ages were tainted with suffering. Again, we find the same theme. Civilizations rise, decline, and vanish, only to be remembered as stories. What makes these myths fascinating is their resonance with what geology now tells us. We know the Earth has passed through cataclysms, asteroid impacts, supervolcanoes, mass extinctions, ice ages. We know that entire ecosystems, even entire lineages, have been wiped out abruptly. To ancient people, without the tools of science, the memory of natural disasters would have been overwhelming. A flood swallowing valleys, a volcanic eruption burying cities, a drought ending kingdoms, all could easily become the seeds of myth. But what if, beyond natural memory, some myths preserve faint echoes of forgotten civilizations? It is not unthinkable. Oral traditions can preserve memories for thousands of years. Aboriginal Australians carry stories of coastlines swallowed by rising seas at the end of the last ice age, events from more than 7,000 years ago. Archaeological studies have confirmed that these stories align with real geological changes. If oral tradition can carry memory across millennia, might some myths carry whispers from even deeper times, distorted but not entirely lost? At the very least, the universality of myths of destruction suggests a deep human recognition that permanence is an illusion and that civilizations are fragile. Whether through floods, fires, or divine judgment, cultures have long intuited what geology later confirmed, that the earth moves in cycles of creation and ruin. In this sense, myths are not evidence of forgotten civilizations, but reflections of a truth written into the planet itself. And yet, the similarity of these myths across distant cultures raises intriguing possibilities. Did people across the world independently imagine the same cycles because they observed the same patterns in nature? Or are there deeper reasons, perhaps shared cultural memories, of catastrophic events that destroyed not just landscapes, but entire societies? Could the archetype of the lost civilization be humanity's dim instinct, echoing through myth, that we might not be the first intelligent beings to walk here? Myths give voice to the silence of the fossil record. Where geology leaves gaps, stories fill the void with imagination, symbolism, and memory. They are humanity's way of grappling with absence, of giving shape to mysteries that science has not yet explained. Perhaps that is why tales of Atlantis, Lemuria, Mu, and countless other lost lands still fascinate us. They speak to something deeper, the intuition that what we see is not all there is, that beneath the surface lies a forgotten past. In the end, whether myths preserve echoes of truth or only metaphors, they matter because they remind us of our fragility. They warn us that worlds can end, that civilizations can vanish, that nothing is eternal. And in that warning lies a mirror. When we listen to myths of lost worlds, we are also hearing our own possible future, a story of disappearance, of survival, and perhaps of someone far in the future telling tales of a world that was, a world now gone. If humanity were to vanish tomorrow, what would remain of us in the deep time of Earth? It is a sobering exercise, one that scientists, writers, and philosophers have attempted to imagine. To step into this thought experiment is to see ourselves through the eyes of geology, not as a civilization of cities and technologies, but as a fleeting disturbance etched into stone and sediment. In the first decades after our disappearance, the collapse would be visible. Buildings would stand hollow, streets overgrown, bridges rusting, vehicles abandoned. Without maintenance, skyscrapers would quickly succumb to wind, rain, and fire. Within a century, most cities would resemble ghostly ruins. Concrete would crack, steel would rust, glass would shatter. Forests would reclaim highways, rivers would flood subways, wildlife would return to suburbs. To the human imagination, this might seem like a frozen reminder of our existence. But in geological terms, it is still only the prologue of forgetting. 1,000 years later, most of our structures would be rubble. Paper, wood, textiles, plastics exposed to sunlight would be gone. Only sheltered environments, sealed caves, underground vaults, or the driest deserts might still hold fragments. But these, too, would be vulnerable to slow decay. In 10,000 years, Earth would be nearly free of obvious ruins. Only the faintest outlines of great cities might linger beneath soil and forest, like archaeological sites waiting for discovery. Yet even these would not endure for millions of years. 100,000 years into the future, glaciers may advance again, grinding landscapes flat. Rivers will have carried away rubble, depositing sediments in the sea. Volcanoes will have buried plains under new lava. Earthquakes will have toppled mountains and resculpted valleys. Our monuments, pyramids, statues, skyscrapers, will be indistinguishable from natural rock. The map itself will be changing, coastlines swallowed, new islands rising, continents drifting toward new collisions. By then, the familiar outlines of our world will be alien. But the geological record will not forget everything. Our greatest legacy will not be the things we built, but the chemistry we changed. The burning of fossil fuels has left an unmistakable isotopic signature. In the rocks of the future, a thin layer will show a sudden and sharp spike in carbon, both in amount and in isotopic ratios. Future geologists, whether human descendants or other beings, will be able to detect that something extraordinary happened in our time. It will not look natural. It will look like a rupture, a break in the rhythm of Earth's cycles. Plastics will also leave their trace. While most will degrade, fragments will sink into sediments and become fused with stone. These plastiglomerates, strange hybrids of human material and natural geology, are already forming on beaches today. In the far future, they will be geological curiosities, markers of an age when one species reshaped matter itself. To beings millions of years from now, they may be evidence not of our culture, but of our chemistry. Nuclear activity will leave scars even more unmistakable. Isotopes such as plutonium-244 and americium-243, which do not occur naturally in measurable quantities, have been created by our testing and reactors. Some of these isotopes have half-lives long enough to persist across geological time. They may endure in sediments and rocks as silent beacons, evidence of technology long gone. No volcano, no meteor impact would create exactly these patterns. They are uniquely cultural shadows. Mining and industry, too, will leave traces. We have moved billions of tons of metals, copper, iron, aluminum, rare earth elements, from where nature left them. We have concentrated them, redistributed them, scattered them into environments where they were never before present. While corrosion and recycling will blur these patterns, subtle imbalances in geology will remain, a fingerprint of an age when humans reshaped the crust. Even biology itself will bear our mark. We have domesticated plants and animals on a massive scale, altering ecosystems beyond recognition. We have driven species to extinction at an accelerating pace, creating what some scientists call the sixth mass extinction. This event, unfolding now, will appear in the fossil record as a sudden and catastrophic loss of biodiversity. The future geologist, sifting through layers, will see countless species vanish almost at once, replaced by a world dominated by a handful of domestic crops and animals. This, too, will be a signature, an abrupt and unusual change in the rhythm of life. Thus, our legacy will not be monuments, but anomalies. We will be remembered as a thin, strange layer in Earth's rocks, a carbon spike, a radioactive echo, plastiglomerates, disrupted ecosystems. Our cities will be dust, our art will be gone, our stories will vanish. But the shadows of our presence will whisper from the stone. And then comes the haunting thought: if this is what will remain of us, could something similar already exist in the record? Have we already overlooked another civilization's carbon spike, mistaking it for volcanic activity? Have we dismissed isotopic anomalies as mere accidents of nature? Could the absences and silences in geology be the erasures of cultures long gone, their monuments already dust, their voices already lost, their shadows misinterpreted? This is the mirror the Silurian hypothesis holds up to us. It does not merely ask whether others came before. It asks us to recognize how fragile our own permanence is, to see ourselves not as eternal, but as temporary, to realize that one day, millions of years from now, beings may stand over our thin layer in the rock and ask the same question we ask now. Were they here? Were they the first? Or were they just another verse in Earth's endless song of creation and forgetting? Imagine, millions of years from now, the Earth has changed beyond recognition. Continents have shifted, oceans have opened and closed, mountains have risen where plains once stretched, and entire climates have transformed. On this altered world, a new intelligence emerges. It may be descended from us, or it may be something entirely different, an evolved mammal, a bird, perhaps even something we cannot now imagine. Like us, they become curious. Like us, they search for their place in the story of the planet. And like us, they look to the rocks, the sediments, and the fossils for answers. What would they find? At first, they would find silence. Most of our structures, our monuments, our machines, gone. The cities that once glowed with light would be flattened ruins buried beneath sediment or eroded into nothing. The great wonders of our time, from towering skyscrapers to colossal dams, would be indistinguishable from ordinary rock. The digital age, so vital to us, would be entirely invisible. Hard drives, servers, satellites, even entire constellations of technology would have decayed long before their time. To these future archaeologists, it would appear as though nothing intelligent had lived here at all. And yet, if they looked closer, if they had the patience to read the subtler signs, they might notice whispers of something extraordinary. A thin sedimentary layer, unlike those above or below it, marked by a sudden spike in carbon isotopes. This would tell them of a period when the atmosphere shifted rapidly, warming the planet in an unusual and abrupt way. They would wonder, what could cause such a sudden change? Digging deeper, they might find traces of unusual isotopes, plutonium, americium, cesium, embedded in ancient sediments. These elements would not match the natural rhythms of Earth. Volcanoes, meteors, supernova dust, none would explain them. And so the archaeologists would ask, what kind of force could create such anomalies? What kind of event could scatter materials into the crust that nature never makes? They would also find plastiglomerates, stones infused with the remains of synthetic polymers. To them, these would be a puzzle. Natural processes fuse materials all the time, lava melting stone, minerals crystallizing. But here, the polymers would appear alien, their molecular structures unlike anything found in natural geology. To the sharp eye, this would be evidence not of accident, but of design. And then they would notice something stranger still, the fossil record of our time. A sudden and dramatic extinction event, species vanishing in rapid succession, coral reefs collapsing, forests shrinking, large mammals disappearing. In their place, the overwhelming dominance of a few species, cattle, chickens, pigs, wheat, corn, rice. The fossil record would show an explosion of these organisms in numbers never seen before, followed by their equally sudden decline. To any careful observer, this would look like manipulation, not nature, but agriculture. Together, these clues would tell a story, not complete, but compelling. A story of a civilization that once rose, reshaped the planet, and then disappeared. These archaeologists might debate fiercely what it meant. Some would argue it was natural, a volcanic surge, a cosmic accident. Others would insist the anomalies point to culture, to intelligence. They would stand in lecture halls, hold debates, write papers, perhaps never fully agreeing. But the suspicion would remain. Something intelligent lived here once, something that left shadows in stone. And yet, there would be no monuments, no intact cities, no words to read, no voices to hear, only chemical scars, biological distortions, isotopic anomalies, and hybrid stones. Would they be enough to convince, or would they remain, as they do for us when we study the past, Tantalizing mysteries, always possible, never certain. This is the irony. We, too, debate anomalies in the geological record. The Paleocene-Eocene thermal maximum, unexplained carbon surges, sudden warming events, metallic spikes in sediments. We study them, propose theories, and argue whether they are volcanic, cosmic, or something else. We stand in our lecture halls, debating like those future beings might, wondering whether intelligence left traces before us. The cycle repeats, not only of civilizations rising and falling, but of curiosity itself. Each age asks the same question: am I the first, or am I standing on forgotten foundations? If those future archaeologists did conclude that a civilization once existed in our time, what would they think of us? Would they see us as careless destroyers who altered the planet too fast? As visionaries who briefly touched the stars? As a species that burned bright but briefly? Without our words, without our voices, without context, they would see only fragments. They would have to imagine the rest, as we do when we reconstruct dinosaurs, trilobites, or ancient forests from scraps. And so the final irony is this: even if we are remembered, we will be remembered imperfectly. Our story will not be told by our monuments or our art, but by the unintended shadows we leave behind. We will be interpreted through anomalies, reconstructed from scars. We will be debated as mysteries. To the far future, we may be no more clear than the civilizations we ourselves now wonder about. Science, at its heart, is the art of pattern recognition. We look into the chaos of the natural world and try to find order. We measure, compare, categorize, and search for meaning in the fragments left behind. And nowhere is this clearer than in geology and paleontology, the sciences that attempt to reconstruct entire worlds from a handful of clues. Consider how much of Earth's history we have pieced together from anomalies. A thin layer of iridium, only a few centimeters thick, scattered across the globe, told us of an asteroid strike that ended the reign of the dinosaurs. Without that anomaly, we might still be debating what caused their extinction. The Permian Great Dying is known from abrupt chemical changes in rocks, sulfur spikes, carbon imbalances, isotopes that speak of massive volcanic activity. Without those anomalies, the event would be invisible. This is how science works, by finding irregularities in stone and sediment, then building stories around them. Most of the time, those stories are about volcanoes, meteors, or climate cycles. But what if some anomalies resist these explanations? What if some do not fit comfortably within the rhythms of geology? At what point does the possibility of forgotten civilizations enter the conversation? Already, there are cases that provoke curiosity. The Paleocene-Eocene thermal maximum, around 56 million years ago, shows a sudden surge of carbon dioxide and global warming. Current explanations point to volcanic activity or methane release from the oceans. But to some, it looks eerily similar to what we are doing today. Could it have been the shadow of another civilization? Most scientists doubt it, but the very fact that the question can be asked shows how narrow the line is between natural and cultural anomalies. Another example: certain metallic concentrations found in sediments that appear unusual, though often explained by cosmic dust or volcanic ash. Could some of these, however, be industrial residues? So far, no evidence has compelled consensus, but the search continues, because science thrives on asking questions that stretch imagination. To approach such mysteries responsibly, scientists develop frameworks. They ask, what would unmistakable evidence of intelligence look like in the deep past? The answer is rarely ruins or artifacts. Those would not survive millions of years. Instead, The answer is chemistry. Isotopes that do not occur naturally. Molecular structures that biology and geology cannot produce on their own. Disturbances so precise, so patterned, that they cannot be dismissed as accident. This is why researchers who ponder the Silurian hypothesis focus on isotopes, plastics, nuclear residues, and biodiversity shifts, because these are the things that might endure when all else is gone. And yet, even with this framework, the challenge remains interpretation. The Earth produces anomalies constantly. Volcanoes create sudden carbon surges. Impacts scatter exotic materials. Ocean currents shift climate in abrupt ways. Nature is inventive, and it often mimics what we think of as cultural fingerprints. The danger is not only missing signs of intelligence, but also seeing intelligence where there is none. Science must walk the thin line between skepticism and imagination. What makes this search remarkable is that it mirrors other frontiers of exploration. When astronomers look for life on exoplanets, they also search for anomalies, atmospheric compositions that should not exist naturally, heat signatures that hint at technology, or chemical patterns inconsistent with geology alone. The principle is the same. Look for what is out of place, what breaks the rhythm of nature. Whether scanning distant worlds or digging into our own past, the method is identical. We are searching for shadows of intelligence. Perhaps one day, geologists will stumble upon something that cannot be dismissed so easily. A layer rich in isotopes that do not belong. A mineral fused with polymers that have no natural origin. A biological shift too abrupt, too peculiar, to be explained by natural disaster. Perhaps it will not be proof, but it will be a question that will not go away. It will spark debate, research, and controversy, just as iridium once did for the dinosaurs. The possibility itself is powerful. It reminds us that science is not only about what we know, but about what we are willing to ask. The Silurian hypothesis is not embraced because it proves forgotten civilizations, but because it forces us to sharpen our tools, to look more closely, to refine our understanding of anomalies. In seeking what may not exist, we become better at reading what does. And if, in the process, we discover that we are not the first, that intelligence rose before us and vanished into silence, it would not only rewrite history, it would change how we see ourselves. We would no longer be the lone voice in Earth's song of life, but one verse among many. A reminder that civilizations, like species, come and go, leaving only faint signatures in the stone. Until that day, we continue the search. Every drill core, every fossil bed, every chemical analysis carries with it not just the story of geology, but the possibility of mystery. Perhaps the most extraordinary discovery waiting for us is not out there in the stars, but right here beneath our feet, in the deep memory of the Earth, where shadows of the forgotten may yet whisper. When we ask whether forgotten civilizations could have walked the Earth, we are not only speaking about geology, we are also speaking about how we look for life and how we search for intelligence beyond our world. Because the methods overlap. Whether scanning a distant exoplanet, probing the crust of Mars, or drilling into Antarctic ice, the guiding question is the same. What looks out of place? What breaks the rhythm of nature and suggests intention? Consider Mars. The red planet fascinates us not only because it is a neighbor, but because it bears scars of water. Dry riverbeds, ancient deltas, and mineral deposits all point to a time when Mars had flowing rivers and possibly oceans. If life ever arose there, it may have flourished billions of years ago, long before Earth's own familiar creatures appeared. Today, we scour Martian rocks for chemical anomalies, traces of methane, isotopic ratios, organic molecules. The search is not for cities or monuments, but for whispers. If intelligent life had ever touched Mars, its monuments would already be gone, erased by dust storms and eons of erosion. Only chemical scars might remain. Venus tells a different story. Once it may have had oceans, perhaps even conditions hospitable to life. But a runaway greenhouse effect transformed it into a hellscape of crushing pressure and acid clouds. Its surface has been resurfaced by volcanic activity, erasing nearly all evidence of the past. If a civilization had ever lived there, its traces would be buried beneath lava plains, indistinguishable from natural geology. Some scientists speculate about life in the clouds of Venus even today. Not intelligent civilizations, but microbial colonies adapted to acid. And again, the search comes down to anomalies, unexpected chemical signatures in the atmosphere that do not match simple geology. Beyond the inner planets, we look to the icy moons of Jupiter and Saturn. Europa, Enceladus, Ganymede, Titan, all hold promise. Beneath their icy crusts lie oceans, warmed by tidal heating and chemical reactions. Space probes have detected plumes of water vapor erupting from Enceladus, laced with organic compounds. Titan's methane seas mimic Earth's water cycle, with lakes, rivers, and rain, except in hydrocarbons, not water. These are alien environments, but the principle of the search remains the same. We do not expect to find cities beneath the ice. We look instead for chemical irregularities, molecules that biology, but not geology, would create. Even when we turn our telescopes outward to distant exoplanets, the same logic applies. Astronomers search for biosignatures in atmospheres, oxygen, methane, carbon dioxide, in combinations that cannot exist without life. Beyond that, they dream of finding technosignatures, patterns that might indicate intelligent activity. This could be industrial pollutants, artificial light on a planet's night side, or even massive engineering projects, visible as anomalies in starlight. Again, the evidence would not be monuments, but shadows of technology, read from afar. What connects all these searches is humility. We know that worlds are not static. They change. They erase themselves. Time is cruel to memory. Whether on Earth, Mars, or Venus, the past is fragile. And so the search for life, whether ancient microbes or forgotten civilizations, becomes a search for the improbable survivors, the anomalies that time cannot erase. This brings us back to Earth. If we are willing to search Mars for isotopic ratios and Venus for strange chemicals, why not apply the same curiosity here? If we are ready to believe that anomalies in exoplanet atmospheres might mean technology, why not entertain the possibility that anomalies in our own sediments might mean forgotten ages? The principle is the same. The difference is only perspective. It feels stranger to imagine civilizations here because we want to believe we are unique. And yet, perhaps we are not. Perhaps intelligence is not a one-time accident, but a recurring possibility. Perhaps Earth has produced it before and will again, long after we are gone. If so, then our search on other worlds is not just about them. It is also about us, about recognizing that the universe, and even our own planet, may be richer, more layered, and more mysterious than we dare to assume. In the end, the comparison teaches us this: civilizations, if they leave traces at all, leave them in shadows, not monuments. And whether we look down into Earth's rocks or out across the stars, we are always searching for the same thing: patterns that should not be there, whispers of intelligence carried across impossible spans of time and space. Human beings have always told themselves that we are special. Across cultures, across centuries, We imagine ourselves as the pinnacle of creation, the final chapter of evolution, the purpose of the cosmos. Religions teach that humanity was crafted by divine hands. Philosophers argue that reason sets us apart from all other creatures. Scientists, even as they measure our smallness in the universe, often describe us as unique in our intelligence. This belief in uniqueness comforts us. It gives our story meaning. But the Earth itself tells a different tale. For billions of years, life has been experimenting, diversifying, evolving. Intelligence is not an endpoint, but one of many adaptations. Dinosaurs evolved complex social structures. Birds and mammals show remarkable problem-solving abilities. Octopuses use tools and display flashes of creativity. Intelligence, in one form or another, has appeared many times. Why then should we believe that it appeared only once at the level of civilization? Why should we assume that we are the first and only species to transform the planet consciously? Part of the answer is pride. We see ourselves as standing above nature rather than within it. We imagine our skyscrapers, our machines, our digital networks as permanent achievements, proof that we are different. But when viewed through the scale of geology, these become as fleeting as seashells on a beach. The tide of time washes them away just as surely. Our uniqueness dissolves into the broader rhythm of rise and fall, creation and erasure. Another part of the answer is fear. If we are not the first, then what happened to those who came before? Did they collapse under their own weight? Did they destroy themselves with their own technology? Did they vanish in catastrophes that we too might face? To admit the possibility of forgotten civilizations is to admit that our own permanence is fragile. It forces us to confront the idea that intelligence may not be salvation, but vulnerability, that the very tools that raise civilizations also sharpen their downfall. Science itself, though guided by evidence, is not immune to this bias. Many researchers instinctively resist the idea of prior civilizations, not because the evidence disproves it, but because the thought feels unnecessary, even dangerous. Extraordinary claims require extraordinary evidence, they say, and they are right. But the line between skepticism and pride is thin. We often demand more proof for ideas that unsettle our place in the story. And what idea could be more unsettling than the possibility that we are not the first intelligent species on Earth? This is why the Silurian hypothesis is so provocative. It does not assert that forgotten civilizations existed. It simply reminds us that our evidence is incomplete, our record fragile, and our assumptions deeply human. It asks us to let go of pride long enough to consider the possibility. In doing so, it exposes the tension between our need for uniqueness and the reality of Earth's cycles. Think of how we react to the idea of life on other planets. We are eager to believe in microbes on Mars, in oceans teeming with strange creatures beneath the ice of Europa, in civilizations orbiting distant suns. We invest billions of dollars and generations of effort searching for them. Yet we rarely ask the same question about our own backyard. Why? Because the idea that others might be out there thrills us, but the idea that others might have been here unsettles us. It challenges our uniqueness, not only in space, but in time. And yet, uniqueness is not necessary for meaning. Our story does not become smaller if others came before us. If anything, it becomes richer. To imagine that intelligence has bloomed more than once is to see ourselves as part of a vast tapestry, a recurring theme in Earth's long song. It means that consciousness is not a lonely accident, but a possibility written into the fabric of life. Our value does not come from being the first or the only. It comes from being part of this great pattern, adding our verse to the endless chorus. Ironically, clinging to uniqueness blinds us. It keeps us from asking questions that could sharpen science. If we refuse to consider the possibility of forgotten civilizations, we may miss anomalies that deserve deeper study. We may dismiss evidence as noise because we fear its implications. To let go of uniqueness is not to accept wild fantasies. It is to keep imagination open, to remain humble before the silence of time. And perhaps humility is the real lesson here. To recognize that we are fragile, to see that permanence is an illusion, to accept that our story, like all others, will one day fade. Whether we are the first or not, we are temporary. Whether we are unique or not, we are part of something larger. The earth does not care for our pride. It remembers in chemistry, not in monuments. And long after we are gone, it will continue its cycles, perhaps welcoming others who will ask the same questions we do. So the question is not only, are we unique? The deeper question is, why do we need to be? When we face the idea of forgotten civilizations, our first instinct is unease. It feels threatening to imagine that others may have risen before us, built wonders, dreamed dreams, and then vanished without a trace. It feels unsettling to know that permanence is an illusion, that even our greatest works will one day be dust. But there is another way to see this, not as despair, but as perspective, even as hope. The Earth's history is not a story of endings, but of cycles. Again and again, worlds have ended, only for life to flourish anew. Mass extinctions destroyed countless species, yet from the ruins came new forms, new possibilities. The end of the dinosaurs gave rise to mammals. The collapse of ancient forests gave birth to new ecosystems. Fire consumes, but in its ashes, seeds sprout. Time is merciless, but it is also creative. If civilizations before us rose and fell, then we are proof that the Earth does not give up on intelligence. If the planet has already hosted cultures now forgotten, then ours is part of a greater rhythm, one verse among many, in an endless chorus. And if we are the first, then we carry the honor and responsibility of being the opening line of that song. Either way, our story is not diminished. It is amplified by scale, made richer by context. This perspective changes how we see our own fragility. Yes, we are temporary. Yes, one day our cities will be gone, our names forgotten, our voices silent. But so too were the trilobites, the ammonites, the dinosaurs, the mammoths, and yet life continued, transformed, and grew. We are part of that same current. Our impermanence does not erase our meaning, it deepens it. Think of fireflies. Their glow lasts only seconds, yet in the darkness, it is unforgettable. Human civilization may be brief in geological time, but in its brevity, it shines brightly. We are the only species we know that contemplates the cosmos, writes poetry, builds telescopes, and wonders about forgotten ages. That is not trivial. That is extraordinary. Our impermanence makes our creativity even more precious, because it is fleeting. The recognition of cycles also gives us humility. If others came before us and fell, we must ask, why? Did they destroy themselves with their own ambition? Did they exhaust their resources, poison their world, or fall to the very forces they tried to control? If so, then their silence is a warning, a message written not in words but in absence. Do not repeat our mistakes. If they did not exist, then the silence is still a warning, for it shows how easily time erases. In either case, we are reminded that wisdom lies not in pride, but in caution. And yet, within this humility lies strength. For to know that nothing lasts forever is also to know that everything matters now. Our choices, our art, our kindness, our knowledge, they may not endure millions of years, but they shape the present, and through the present, they shape the future. We may not be able to control what Earth remembers, but we can control what we give to each other, here and now. There is also beauty in the thought that we may not be the last. Even if humanity disappears, even if we fall as others may have fallen, the Earth will remain fertile ground. Life will return, adapt, and grow. Perhaps one day, another intelligence will rise. They may walk among our ruins, study our shadows in stone, and wonder about us, as we now wonder about the forgotten. And in that, we will live again, not in memory, but in curiosity, in mystery, in the questions that endure. This, perhaps, is the true gift of contemplating forgotten civilizations. It reminds us that we are not eternal, but we are meaningful. It humbles us with silence, yet inspires us with possibility. We are not just a species fighting for survival. We are part of a rhythm that spans billions of years. To know this is not to despair, it is to belong. So let us not fear the cycle of forgetting. Let us embrace it. For in the end, to be forgotten by stone does not mean to be meaningless. It means to be part of a song greater than ourselves, one that has been sung since the first cell stirred in the ancient seas, and one that will continue long after our voices fall silent. As we draw closer to the end of this long journey through time and imagination, the question of forgotten civilizations becomes more than a scientific puzzle. It becomes a mirror. For whether or not others came before us, the act of asking changes how we see ourselves. To contemplate the silence of the past is to confront the silence of the future. To look for shadows in stone is to recognize that we too are shadows in the making. The earth is vast, patient, and unhurried. It has seen continents rise and vanish, oceans spread and close, mountains soar and crumble. It has witnessed billions of species flourish and disappear. Against that backdrop, human civilization is a blink, a flicker, a brief flash of light. Our pride tells us we are permanent. Our science reminds us we are not. The same forces that erased dinosaurs, trilobites, and entire forests will, in time, erase us too. And yet, within that truth, there is meaning. To ask whether forgotten civilizations once lived here is to admit that the planet is not our possession, but our host. We are tenants, not owners. We inherit a world already ancient, already written with countless stories. Some of those stories survive in fossils and sediments. Others are erased forever. And one day, our own story will join them. Fragments remembered, most forgotten, woven into the same cycles of renewal. But here is the paradox. Though we will be forgotten by stone, we are not meaningless. Our impermanence makes our existence urgent. It gives weight to our choices, because they matter now, in the moment we live. It makes our creativity precious, because it shines briefly before fading. It makes our kindness powerful, because it is given in a world where nothing lasts. To live with the knowledge of impermanence is not to despair, but to embrace life more fully. And perhaps this is the lesson the earth has been whispering all along. That civilizations are not measured by how long they endure in geology, but by how deeply they live in their time. The pyramids may crumble, the satellites may fall, the servers may rust, but the ideas, the emotions, the connections we create ripple outward. They may not survive as monuments, but they echo in ways we cannot measure. Through generations, through memory, through inspiration, perhaps even through the curiosity of beings who come long after us. This perspective also humbles us in another way. If others did come before us, then their absence is a warning. They may have fallen to their own pride, to their own mistakes, to the same illusions of permanence that tempt us now. If no others came before, then our responsibility is even greater, for we may be the first voice in Earth's long silence. Either way, we stand at a threshold. We hold tools capable of shaping not only our fate, but the fate of countless species around us. We cannot control the deep time eraser, but we can control how we use the brief window we are given. There is also a deeper beauty here, one that transcends science. To imagine forgotten civilizations is to imagine that consciousness is not unique, but woven into the fabric of life. That the universe itself yearns for awareness, and so intelligence blooms again and again, even if each bloom is temporary. To see ourselves as one bloom among many does not make us smaller. It makes us part of something vast, something ongoing. It means that our story does not stand alone, but joins an unseen chorus. And so, whether or not others walked this earth before us, the very act of wondering places us in their company. By asking, we honor them, even if they never existed. By imagining them, we remind ourselves of our own fragility. By seeking them, we strengthen our ability to read the planet, to listen to its memory, to hear the faintest whispers in stone. In this way, forgotten civilizations are not just a possibility. They are a philosophy, a way of seeing ourselves with humility and awe. Perhaps this is the true gift of the Silurian hypothesis. It does not prove that others came before us. It does not need to. Its power lies in the reminder that we, too, are temporary. That permanence is not the measure of meaning. That the earth is older and more mysterious than we can grasp. And that the question, were we the first, is itself a call to live more wisely, more fully, more humbly, in the time we are given. The story of forgotten civilizations, then, is not really about the past. It is about the present. It is about us, here and now, daring to look into the silence and see both a warning and an invitation. A warning that nothing lasts forever. An invitation to live as though our brief glow matters, because it does. And so, we arrive at the end of our journey. We began with a question, whether forgotten civilizations might have once walked this earth, and we end with a realization that the search is not only about the past, but about ourselves. Perhaps no others came before us, and we are indeed the first to rise to this level of awareness. Or perhaps others did bloom long ago, only to vanish into silence, leaving behind nothing but subtle shadows in stone. In either case, the lesson is the same. We are temporary. Our monuments will crumble, our machines will decay, our voices will fade. Yet this does not make us meaningless. It makes us precious. It makes every moment of creativity, of kindness, of connection, matter all the more. The earth is patient. It does not keep memory in monuments, but in chemistry, in fossils, in silence. And one day, when we too are gone, the planet will continue its endless cycles, perhaps welcoming new voices, perhaps repeating the rhythm again. To know this is not despair, it is wonder. For it reminds us that we are part of something vast, something ongoing, something greater than ourselves. So let us live fully in our brief moment. Let us create, explore, question, imagine. Let us be humble before the deep time of the earth, yet bold in what we give to it. For though we may be forgotten by stone, we can still leave behind a legacy of meaning, if not permanence. And if, millions of years from now, others should wonder about us, as we have wondered about them, let them find not only anomalies in stone, but also the echo of a civilization that dared to ask the biggest questions. That, perhaps, is our greatest gift. Thank you for joining me on this journey through mystery, science, and imagination. Until next time, remember, you are watching Journey Through Time.